In this video, we'll work on problem solving with a problem where we need to use the area formula of a triangle. The directions are: find the area of the yellow region and the area of the white region. The triangles are enclosed in a rectangle. So we know our shape is a rectangle that contains several triangles. There are multiple ways that we could go about solving this, and if you wanted to pause the video and give it a go, you could come back and compare your answer to my answer. Regardless of the method, we should get the same areas. Let's get started. So we'll start by writing down the formula that we need. We need the area formula of a triangle. So since our yellow region is comprised of two triangles, we'll need to find the area of each triangle. Let's call this first one triangle 1, so we'll be finding area 1. We can see that one side is labeled 15 centimeters, so let's make this side our base. Notice that we could not have made this side our base because we don't know the length of it. Some people make the mistake of thinking that the vertical length is the same as the length of this diagonal line segment, but they're actually different. So this 35 centimeters refers to this vertical line segment, not to the diagonal one. But we will be using this one because what we can find is that the height of our triangle 1 will go to the third vertex, and we need to draw a line segment that will be perpendicular with the base or with an extension of the base. So let's extend our base, and we can see that this line is perpendicular. We know it's perpendicular because we were dealing with a rectangle. Rectangles have 4 right angles. So here we can say that our height is 35 centimeters. We're ready to calculate the area. The area of triangle 1 is 262.5 square centimeters. To find the area of the yellow region, we'll have to find the area of the second yellow triangle, and then we'll add area of triangle 1 to area of triangle 2 to get the total yellow area. We can use the same strategy here that we used for the other one. Here we have a base because the side is labeled. We wouldn't choose this side or this side as the base because we don't know what the length is. This 40 centimeters is the horizontal distance, not this diagonal one. We choose the vertex that's not part of the base, and we know that we need to draw a line segment from that vertex to the base or to an extension of the base. So let's extend this base. The line segments are perpendicular, so we will call the height this 40 centimeters. Now we're ready to calculate the area. So the area of triangle 2 is 300 square centimeters. To get the yellow area, we'll just add these two together. The yellow area will be 562.5 square centimeters. Let's copy our picture, record what we know, and continue with this problem. To find the area of the white region, we don't have enough information to find the area of each white triangle and add them together. We don't know the base of this triangle. We do know its height. We don't know the base of this triangle. We do know its height, but we don't have enough information. So we're going to use a different strategy. We're going to use the takeaway strategy, where we look at the area of the full rectangle, and we take away the parts we don't want, the yellow parts, and we'll be left with the area of the white region. So to start with, we need the area of the rectangle. We know the area formula for the rectangle is the length of the base of the rectangle times the length of the height of the rectangle. Here we have the base of 40 centimeters and the height of 35 centimeters. The area of the rectangle is 1,400 square centimeters. Now let's do the takeaway. The area of our white region is 837.5 square centimeters.